Now we go on to see some of the general aspects of the sine function, or the basic and the first trigonometric functions. Okay, so this is the graph of sine x, which is 0 at 0, and as the angle increases from 0 to pi by 2, the value of sine increases. As you can see, the length of the perpendicular goes on increasing as as the angle goes from 0 to pi by 2 from in the first quadrant, and after that, from pi by 2 to pi, the value goes down as the length of the perpendicular is tending to 0 again. And similarly, for the values when x is ranging from pi to 3 pi by 2, the sign goes in the third quadrant where it is negative, and the length of the perpendicular is increasing, so it will increase in the negative direction and decrease thereafter. So the graph comes out to be something like this. And to analyze it completely, let's write the domain and the range of the function also. So as you can see, the domain is the values of the x which we can put in the function, which as you can see is r. So domain is equal to r in this case for this function, and range is equal to -1 to 1, as the sine function is bounded function and it lies between -1 and 1. -1 and 1, which is attained, 1 is attained at pi by 2 and -1 at minus pi by 2. So the domain and the range of the function is this. Now let's analyze what is the graph of the tangent function. The tangent function is not defined at pi by 2 because as you recall, tangent of an angle is equal to sine x upon cos x, and at x equal to pi by 2, or say n pi plus pi by 2, the value of cos x is equal to 0. So therefore the tangent function is not defined at n pi plus pi by 2, and the graph comes out to be something like this. As you will recall from the Trigo table I displayed, the value at x equal to 0 is 0, and at x equal to pi by 4 it is 1, and at x equal to pi by 2, as we go close on, as x goes to pi by 2, the value of the tangent function goes on increasing to infinity, and the value is not defined at pi by 2. So the graph comes out to be something like this, and for the negative side, the graphs is goes on decreasing to minus pi by 2, as the value of sin x is negative in this case, and negative for the from 0 to minus pi by 2, and cos x is positive, so the overall function is negative. Similarly, we should, for complete analysis, write the domain of tangent function. So domain is equal to the values for which the tangent function is defined, which is, as you can see from the graph, is r minus the values where it is not defined, or cos x is 0, that is n pi plus pi by 2, where n epsilon n and epsilon z, and the range is equal to minus infinity to infinity, as it takes values from minus infinity to infinity. So range is equal to r. Next we look into some of the basic important properties of the trigonometric functions. It will help you to find the trigonometric ratios of various other angles if a certain angle is given. So let's see for the first property that sine minus x equals to minus sine x. For a very informal proof, let's say this is a unit circle subtending an angle x, and this is a point P which is equal to a comma b. So sine x would be equal to भाई काम कर रहा हूँ. So sine x is equal to a, and if we draw the same angle in the negative direction, which will be minus x, then this point P, or say let's say P1, will be just a reflection in the y-axis, in the x-axis. So it will be P1 will be equal to a comma minus b. Oh sorry, sin x will be equal to b here. I was mistaken here. Sin x equals to b, and sine of minus x would come out to be minus b, which is minus of sin x. Therefore, the property is proved. So similarly, you can see that cos x is equal to a here, and cos of minus x is also a. Therefore, the property is satisfied. We'll use this property to generalize some of the basic things in the next for the next properties. So let's look into how to prove cos of x plus y is equal to cos x cos y minus sin x sin y. This probably will be used or will be helpful in solving the next properties and the corresponding examples. So let's take a unit circle in which where there are 4 points P4, which lies on the x-axis. I haven't drawn the axis because otherwise the proof will be somewhat tedious. So to make it clear, uh, just if you want, put this y-axis here. P4. So let's start. P4 is a point which lies on the x-axis, which is equal to 1 comma 0. P1 is a point subtending an angle x on at O, and P2 is a point which subtends an angle x plus y at center, and P3 is a point which subtends angle minus y from minus y uh, at the center. So to solve this, first of all, we need to we start by proving that the triangle P1 O P3 is congruent to P3 O P4. So to prove this, first of all, see that P1 O is equal to P3 O is equal to 0, as is these are the radius of the circle, and similarly OP3 is equal to OP4, as they are also the radius of the circle and of unit length, and the corresponding angle, that is P1 OP3 P1 OP3 sorry P1 OP3 will be equal to uh, for finding P1 OP3, this will be equal to this. Let's say y is an angle of measure a degree and x is of measure b degree. Then minus x will also be a measure of a degree, and y minus y will also be a measure of b degree. So the angle P1 OP3 will be equal to the total circle, that is 2 pi, minus the measure of angle x, that is a degree, plus the measure of minus y, which is equal to b degree. Okay, so angle P1 or P3 is equal to this. Similarly, you can work out what is the measure of angle P2 or P4, which will be again the whole angle 2 pi minus x minus y. So will be again come out to be 2 pi minus a degree plus b degree. There will be P2 or P4. Therefore, the by the SAS property, that is side angle side, as you may recall, the side and the included angles and the side is equal, then the triangles are congruent. Therefore, the sides P1 P3 will be equal to P2 P4. So let's try to find out what are these sides. So let's find this P1 P3 by the distance formula. So P1 P3 will be equal to, as you can simply figure out, P1 is equal to cos x comma sin x, and P3 is equal to cos of x plus y comma sin of x plus y. Therefore P1 P3 will be equal to, sorry, um, P3 will be equal to cos of minus y, which, as by according to the earlier property, cos y, and sin of minus y, which is equal to minus sin y. Therefore P1 P3 will come out to be cos x minus cos y square, cos x minus cos y square, plus sin x minus of minus sin y, which is equal to sin y square. So putting under root doesn't seem very nice, so let's put a square here. P1 P3 square equals to this, and after solving out and using the equation that cos square x plus sin square x is equal to 1, and similarly cos square y plus sin square y is equal to 1, we will get the result that this particular is equal to 2 minus 2 cos x cos y minus sin x sin y. Similarly, let's look into what is P3, what is P2 P4. So to find P2 P4, P2 will be equal to cos of x plus y comma sin of x plus y. So P2 P4 will be equal to, so P2 P4 square, for the clarity sake, P2 P4 square is equal to 1 minus cos of x plus y square plus sin square of x plus y. Therefore, it'll, after solving and using the equation that cos square of x plus y is equal to plus sin square x plus y, cos square x plus y plus sin square x plus y is equal to 1, we'll get 2 minus 2 cos of x plus y, and hence these two are equal, their squares will also be equal. So after equate the from equation 1 and equation 2, you will get, as the 2's will cancel and this minus 2 will also cancel, you will get the following property: cos of x plus y is equal to cos x cos y minus sin x sin y. Next we try to prove that tan x plus y is equal to tan x plus tan y upon 1 minus tan x tan y. It is the very easy, uh, it is what I, this is a very, this is my favorite property. And to prove this, let's start by basic definition that tan of x plus y is equal to sin x plus sin y, sin x plus y upon cos x plus y, which is again equal to, by expanding, so you have by expanding sin x plus y, as I've shown in the earlier example, or you can also work out this by the earlier property cos of x plus y. Let's go back. Cos, by taking pi is equal to, sorry, x is equal to pi by 2 plus y, or say pi by 2 minus y. Take pi by 2 plus y, it'll be easier. So after after solving this equation, you will get sin x plus sin x plus y is equal to sin x cos y plus sin y cos x, and cos of x plus y is equal to cos x cos y minus sin x sin y. If you divide this equation, the numerator and denominator, by cos x cos y, you will get uh, simply sin x upon sin y, sin x upon cos x plus sin y upon cos y whole upon 1 minus sin x cos y sin x cos x sin y cos y. And as you can recall that sin x upon cos x is equal to 10x, and hence you get the property 10x plus y 10x plus 10y upon 1 minus 10x 10y.